Alrighty guys, we are going to add to our notebook again today. This time we're going to talk about something pretty new and can get sort of tricky. Not to like scare you, but just to prepare you. We're going to start very simply today, but in the future we're going to increase the complexity a bit. So we're going to talk about area of regular polygons. And if you remember, what it means to be regular is that all the sides are the same and all the angles are the same. So these are like not irregular shapes. They're not like all kind of weird and contorted. They look really nice. They're any size polygons, so it could be quadrilateral, pentagon, hexagon, heptagon, octagon, all of those. I actually have to look. We're going to do this on a couple of different pages. So we're going from 111 until I think 115. Yeah. We're obviously not going to do all that in this video here. In fact, we're only probably going to do 111 and maybe 112, but all that stuff in there is going to be area of regular polygons. Maybe I'll specify some of the little like subcategories on each of those. So let's turn to 111 and start with some terminology. So it doesn't have to be a triangle, quadrilateral, or hexagon. This applies to all polygons, but there's some new sort of terminology that we need to look at here. So firstly, this is a side of a triangle. This is a side of the quadrilateral. I know it seems silly, but this is a side of the regular hexagon. So we need to make sure that we're identifying the side and how long it is. Finding the side length is going to be super crucial to finding the area of regular polygons. Another thing that we need to identify is actually something called the center. So this right here is the center of my shape. It's almost like you want to think about a circle being around it, and it's almost like the center of a circle, except I get rid of the circle and I have a triangle left. So like almost think of a circle coming around this, and this is the center of the circle. It's also the center of the triangle if it's regular, because a regular shape will fit inside of a circle perfectly. So here I have, oh my goodness, I just drew all over myself. Center. And then right here, we have a center. The center is crucial. And understanding that it's like the center of a polygon, but also the center of a circle is important. Next. If I have a line coming from the center to an angle, this is like where your circle is coming around. So really, that is a radius of the shape. So it feels weird to call a thing in not a circle a radius, but it's a radius because there's kind of this circle coming around the shape anyways. So from center to angle is a radius. Maybe let's make that note. Radius is center to angle. And we have one there. Radius. Okay. And then the last one that I have for you here is kind of the newest one. Like, obviously we know a side. We kind of understand what a center is in terms of circle and a radius is. Now we're just putting them inside other shapes. But this last one is super new. So this right here on all of these shapes kind of looks like a height. Like if you think about it, it's got that 90-degree box. We're talking about heights. Height's got to have a 90. The only problem is it's not like the full height of the shape. So I can't call it a height. But so I do give it a new name, but it is kind of like a height. It's really the height from an edge to the center, and we call this an apothem. So it kind of sounds like you're saying a possum with a lisp. Apothem. So the apothem is a height, and I'm going to make this note down here. So an apothem is a height, but it goes from center to side, which is important. Like, I do need to understand the difference between a radius and an apothem. They're not the same. A radius goes from center to angle. An apothem goes from center to side, and it is like a height. It should have that 90. The reason we need to know all of this is because if I want to find the area of a regular polygon, so area of a regular polygon, you can break it up into little pieces and then add up the sum of its parts. But what ends up happening is you come up with this formula, area equals half AP, where A stands for that apothem, which is why I need to know what it is, where it is, how I find it. And P stands for perimeter, which is why it's important that we talked about perimeter again. Now, perimeter here, just like add up all the sides. However, your sides are all the same. So, because it's a regular shape. So when I think about perimeter, I actually kind of think about it as the side times the number of sides. So side times number of sides, because they're all the same. So like if I know the side length of this triangle here is 8, I would just do 8 times 3 because they're all the same. 8 is the side, 3 is the number of sides. Or if I'm looking at a square, which is a regular quadrilateral, if I know the side length is 7, I'm doing 7 times 4 for the perimeter. Or for my regular hexagon, if I know the side length is 5, I'm doing 5 times 6 because the side length is 5 and there are 6 sides. So really, really basic example here. If I said that a regular hexagon with side length of 9 inches and an apothem of 7 inches, and I wanted to find the area, they've given you everything that you need. You just need to plug it all in. So because my area formula here is half apothem times perimeter, I would do half the apothem, which is 7, times the perimeter, which perimeter I'm really thinking of as the side times number of sides. So the side length is 9, and there are 6 of them. So really I'm just multiplying up a whole bunch of numbers here. I'm going to take half of the only thing I can, which is the 6. And so I end up with 7 times 9 times 3, or 21 times 9. Felt like the easiest way to multiply that to me. So 21 times 9 is 189 inches squared for that area. Okay, so sometimes they're super basic and they give you exactly what you need to find the area sometimes. So looking at page 112, let's actually do some of these. So we're going to use our half perimeter times apothem for all of these. I wrote it backwards and I hate it. Perimeter is going to come from sides. Here's our apothem, here's our apothem, here's our apothem. All the other sides in there are shown as radii. So if we take a look at this first one here, if I want to find the area of this regular triangle, I want to do half apothem times perimeter. which unfortunately they have not marked my apothem for me, and they haven't given you your side length. So because you know it's a regular triangle, this one is maybe a little bit simpler. We can think of this a couple of different ways. I know in a triangle that, or in a regular triangle, that each angle is 60 degrees. But you've drawn this radius right through it, and so you split that 60 in half, and now it's 30. And this one up here is 60, because you got a 30, 60, 90 triangle. And so on that 30, 60, 90 triangle, this little guy in the middle here, so like that's really where you're focused on, because that will actually find you your apothem, and it'll help you to find your side length. You know the hypotenuse is 4, so if you want to get that shorter side, the one across from the 30, it's half, so 2. And then the one across from 60 is root 3 times as much, so 2 root 3. Now the reason that that's helpful is because when you drop that apothem down, you split that side equally in half. And so this side is also 2 root 3. And so now I have the side length and my apothem, and I can find everything. So we're going to do half apothem, which was 2, times the perimeter, which is going to be the side length, which is a full 4 root 3, times 3 of them. So you can take half of whatever you want. I want to take half of 2 because that's easy. It just goes away. And so really I just have 4 root 3 times 3, which is 12 root 3. Oops, I have like spots for apothem and perimeter. I'm not going to fill that out. We found it. It's fine. Okay, let's try one that's a little bit backwards. So find the area of a regular triangle with a perimeter of 96 root 3 units. Wait, what? Area equals half apothem times the perimeter, but I need the apothem. Well, if we think about this, if it's a regular triangle, and that's the perimeter, I can split it equally between all 3 sides. So if I divide this by 3, I get 32 for each of the sides. But then when I draw this apothem in there, it splits that 32 root 3 in half again. And so like I kind of have 16 root 3 on either side, which is helpful because if I want to find the apothem, just like with that last one, I mean, it's the same right triangle, it's just scaled up. It's still going to have this little 30, 60, 90 triangle in right here. So like where this was 30 degrees. And now you know this side across from 60, which is where the root 3 is supposed to be. And so I just take it off to get the small side. And so your apothem is just 16. So I can take half of whatever I want. I think I want to take half of, I don't know, the 16 just seems easier to do in my head. And then I'm going to do 8 times 96, which is real big. So I'm going to grab my calculator. 8 times 96. Holy smokes. 768 root 3 units squared for that area there. That's crazy. All right, trying another one on a slightly bigger polygon. Looking at a regular quadrilateral, which is really just a square. And so it's kind of annoying because like finding the area of a square can be super easy where I just do base times height or side squared. So if I want to find the area of this regular quadrilateral, the problem is they didn't tell me the side, and so I can't do that. What they've given me here is the apothem. So that's why I want to use half apothem times perimeter. Now the problem is I do know the apothem, but since I don't know the side, I can't really find the perimeter. But again, if I think about the angles, because like I can know the angles in the corners here. In a regular quadrilateral, aka a square, they're each 90. But then this one, when I drew in that radius, got split right in half. So you're really looking at a 45, 45, 90 triangle, which in a 45, 45, 90 triangle, the legs are the same. And the hypotenuse is 10 root 2 times as much. Although I don't need that radius, I really just needed this side down here, which is 10. And when you drew your apothem split it in half, so this side is also 10, meaning that the full side length of the square is 20. So now I can find the perimeter because there are 4 of those 20 length sides. So I can take half of whatever I want. I'm going to take half of 20. So I really have 100 times 4, which is 400 units squared. Now the really cool thing that I like to show with this one, because we do understand how to find the area of a square, it's just going to be base times height, which is 20 times 20, which is 400, which is so cool. Okay, let's try another. Find the area of a regular quadrilateral, aka a square, with a perimeter of 16. Now truly, I could do half apothem times perimeter here, which seems like a good idea since they've told me the perimeter is 16, but I don't know the apothem. But like with this last one here, because perimeter and the side lengths are the same, I can just take that 16 and split it equally between all 4, which means that each side is 4. So I mean, like low-key right now, I already know that the area is 16 because 4 times 4. But just to practice our half apothem times perimeter, if I draw that apothem in and I make that same right triangle, it's still going to be a 45, 45, 90. The apothem split the 4 in half, so it's 2. So the other leg will also be 2, which means your apothem is 2. And so if I take half of 2, it's 16. Oh my gosh, I just thought of another thing as well, centimeter squared. Your apothem is just half the side length of the side, because it's like right in the center. So on either side, it's got to be 2. Also, a square is a rhombus, so I could do half d1 times d2. And I know that the diagonal here is 2 root 2, but then like the full diagonal is 4 root 2. So half 4 root 2. The other one will be the same because a square is a rectangle and rectangles have the same diagonals. And so when I multiply this, 4 times 4 is 16. Half of that is 8. Root 2 times root 2 is root 4, which is 2, times 8 is 16. Okay, squares and triangles are kind of easy because we're used to those. Let's jump to a bigger shape, a regular hexagon, and try one that's a little bit bigger. So if I want to find the area of a regular hexagon, now let me point something out to you guys. Every single time I've had to find these sort of corner angles. It's kind of harder in a hexagon to find all the corner angles because I have to like know the sum of the angles of a hexagon and then split it equally amongst them. So kind of another way to figure out what your corner angle is, or another way to figure out what are the angles in this little mini right triangle right here that makes up the apothem, is by considering what we call the central angle. So going around the center, I have 360 degrees. If I draw radii coming out to each angle of my hexagon, that splits this into 6 equal hexagon or 6 equal triangles, which that will also happen in like a heptagon. It would divide it into seven equal, because heptagon is 7, or octagon would be 8. So I would divide this equally between the 6. So 6 goes into 36 6 times, so 60 degrees. But then I drop my apothem down, which splits it in half again. And so this top angle right here is 30 degrees, which tells me, again, I'm in a 30, 60, 90 triangle. This one is 60. It's just facing the other direction. So like the triangle had a 30, 60, 90, but the 30 was in the bottom corner. With a hexagon, it's a 30, 60, 90, but the 30 is in the top. So it is a little different. And then after I know the angle, I was able to figure out either the apothem or perimeter, whichever I needed. So in this hexagon here, I do not know the apothem, but I do know that this side length is 24. So I can do 24 times 6 for the perimeter. And that's also helpful to me because when I drop the apothem down on this 24, it splits it in half equally. So I know that on my 30, 60, 90 triangle right here, I have a side length of 12, which is across from the 30, which is your shorter side. And so then the hypotenuse, or not the hypotenuse, the side across from 60 rather, is root 3 times this much. So 12 root 3, which is your apothem. So once I have all my numbers filled in, I can take half of whatever I want. So I'm going to take half of the 24 for 12. And then I have 12 times 12 for 144, but then I got to times that by 6. So I'm going to use my calculator. That is 864 root 3 units squared. Oops, centimeters squared, they told me. Oops, that was inches squared. So silly. Okay. Okay, let's do another hexagon. Find the area of a regular hexagon with a perimeter of 24 units. So, kind of like we did with all these other ones here, because the perimeter is 24, that's great. But I do need to know each individual side, so I can split that 24 up equally between all 6, meaning that each side is 4. But when I draw that apothem in, splits that 4 in half for 2. And really, this is the same right triangle as this hexagon. It's just either bigger or smaller. And so this top angle is still 30 degrees. And so I'm still looking at a 30, 60, 90. Where the short side is 2, and so the long leg is 2 root 3, aka my apothem. So we'll have half times the apothem, which is 2 root 3, times the perimeter, which was 24. You can take half of whatever you want. I'm just going to take half of 2 because it'll get rid of it. And then I have 24 root 3 units squared as my area. Now I should note, if I want the approximate area of any of these, like for this one here, I need to then go multiply by root 3 to get the approximate area. Guys, if this is feeling a little sketchy, we're going to talk about it more, but try your best for now.